champion. I know you are preparing for your DGCA exam, and the exam will be happening within like within 20 to 25 expectedly of this month. So revise करना बहुत important है. You have to revise again and again, again and again. Okay, so it's more about revision than about just marking up the books and then finally not doing anything. एक बार पढ़ने से कुछ नहीं होता है. You have to revise it again and again, again and again. Okay, keep that in mind. Small resource रखो और उसको बार बार revise करो. Keep revising it. So revision is very very important. So this is the first chapter that I am starting for revision, and this revision series I'll try to put as early as possible, and most of the chapters I'll try to complete from Ratan Modia's sum of things, and most of the things are correct over here because these have been taken from the books only, so don't worry about it. Okay, and if there is some confusion about it, I'll make sure I'll not put it in a video so that you people are not confused with that particular point. Unless I am really sure about the answer, I'll not put it for sure. Okay, so incandescent type of light is what type of a light? It is basically a light in which when you pass electricity, it heats up and then the filament starts radiating light. Okay, just keep that much in mind. What is the melting point of the filament? It is 3659 Kelvin. Fine. When electron flow will happen, it will heat up the filament and the filament temperature will rise and that will radiate the light, and that light is called as a incandescent type of light. It is basically the old bulbs that we used to have, the yellow color bulbs. Okay. Electroluminescence is basically LED. In a very simple way, we use a semiconductor material through which when you pass electricity, it will radiate light. So in LED, we know it is a diode, light emitting diode. So in a diode, when you pass electricity, being a semiconductor, it will also give you some sort of a light emission. Okay. Then you have got fluorescent lamps. What is fluorescent lamps? Fluorescent lamps is a type of tube lights only. The tube lights that we have used for so many years, the white color tube lights. Okay, it is a sealed glass tube, we know, and it is having what? The inside layer of the tube is having phosphor coated. It is phosphor coated. Okay, and when you apply high voltage, what happens? There is a mercury vapor inside. That white color mercury vapor will ionize. Ions will form. Okay, mercury ions will form, and that will basically convert into a plasma form. Plasma is basically a very high supercharged ions that will radiate a lot of light. Fine. Okay, then we have strobe lights. Strobe light is basically a type of light which is sealed again, and it is having what? It is having xenon gas within it, and we know that xenon is a inert gas, noble gas, right? Xenon is a inert gas or noble gas. It does not react with any other type of material. Okay, what is the normal diameter? It is approximately 5 mm. Okay, and it is sealed within a glass because it is having a very high voltage that needs to be supplied to it. It is around 400 volt DC, which is very hazardous. That's the reason it is sealed within that particular glass. And strobe light can be used as an anti-collision light. Now anti-collision light is those type of lights which does not allow the aircraft to get collided with another aircraft, get crashed with another aircraft. So it is that type of a light you must have seen at the wingtips, or when at night the aircraft, or the beacon light you must have seen. Okay, it is like it glows, it stops for some seconds and then again it will emit light, and again it will stop and then again it will emit light. So it is like not a constant type of a light. It continuously changes its rate at which it is glowing, and that type of a light can actually drag your attention. Okay, so any emergency light or any anti-collision light at the wing and the tail portions, the beacon light, the red color beacon light. Okay, all these lines are basically anti-collision lights, which does not allow the aircraft to get collided with another aircraft. There is a clear plastic protective layer above it. Okay, through which the light comes out, and it is very stable because it's inert gas. As I told you, it does not react with anything. It is used in LED also. Ionization actually decreases the electrical resistance of the gas. Thus, that pulse in the order of 1000 amperes conduct through gas. Okay, the moment you actually generate some ionization, so that ionization will do what? A lot of current it will produce within the light, and that light will be giving you a very bright spectrum outside. Okay, very bright emission of light outside. Strobes are source of short wavelength. Remember that, short wavelength. So these round the way he has actually encircled, okay, the words that he has encircled, those are the most important ones. And he has also written DGCA, which means it has come in DGCA. So there is already a question in DGCA that strobe wavelength, short wavelength is used in which type of light? It is in strobe light. overall effect is that high intensity white flash. That is also DGCA question. Okay, ultraviolet radiation with a high intensity uh, white flash, and it's a short wavelength. That's all. Next, in flight compartments, what type of lights are there? There is a dome light. Okay, that is basically there in the ceiling, provide a non-directional distribution, which means there is no particular direction. It lights up the entire, when you switch it on, it lights the entire flight compartment, the cockpit. Okay, it is for all general illumination. चारों तरफ साइड पे फैल जाता है. In Hindi, if I say, it means that it will get spreaded in all directions. So it is non-directional. There is no particular direction. It is typically contains an incandescent bulb, the one that we have just read. Okay, where there is a filament which hits up and gives you light. Okay, then it is battery or ground service bus operated, means with GPU or with battery you can power it up. Floodlights are the type of lights. By the word flood, you can understand what is the meaning of flood. Flood means when there is water everywhere. So just like that, over here the lights will be everywhere. So it's a type of a light which is also incandescent lamp or fluorescent tubes, which provides the general illumination of the instrument panel. So it's a type of a light which is given specifically in the instrument panel to light up the entire instrument panel so that the pilot can see it properly. Okay, so it will like flood the entire instrument panel with light, full of light it will be. Fluorescent tube located beneath the glare shield provide overall illumination of instrument panel. So behind every the entire instrument panel there is a fluorescent tube that will also give some good brightness from the back of the instrument panels. Now next you have is emergency lights. What are the emergency light? It is basically flight compartment for escape purpose. If there is some emergency, so that from flight compartment you can easily escape. So that's the reason it is given. It is also it's having the colors normally white. Okay, because in any smoking condition and other conditions, so that it can be the line of escape line or escape route can be easily tracked. White light actually decreases the power and heat, and that also improves the contrast. You can see things very easily. And instrument and eye fatigue, it will decrease the eye fatigue. Okay, this is already a DGCA question. What is the benefits of good white light? It decreases the power and heat consumption, it improves the contrast and viewing, and also it will reduce your eye fatigue. White light is a type of a light that reduces the eye fatigue too much. And always remember, blue light that we use in our mobile phones and computers, that is very harmful, that increases the eye fatigue. So do not use any blue light if you are using it. Okay, stop using it, use a white light. Instruments light, internal instrument light, if there is a particular light given behind each instrument, okay, that is an incandescent lamp normally behind each instrument, I'm saying. Okay, and it must be shielded from causing any direct glare to the pilot. So when he looks at particular instrument, that should not give him a lot of glare means too much bright light causing a very disturbance in the vision. That should not happen, otherwise he will not be able to see what is the reading in the instrument. Okay, external lights could be like which will basically provide which is also called as pillar or bridge light. This is a DGCA question, which is positioned on the panels for individual instrument. For each and every individual instrument there will be a bridge light or pillar light. Okay, mind it, the word is different but the light is same. It is either called bridge light or it is called pillar light, but the function is same. It is for individual instrument. When you see this word individual instrument, you have to understand that it is either pillar light it is talking about, or bridge light. Okay, next is light intensity deemed by what. Now we know that any regulator we use in our household purposes, it is to control or regulate the speed of the fan, right? In the same way, a rheostat, regulator is basically a rheostat. We have all studied in physics in our school level. So rheostat is here also, it is used to dim the intensity of light. So there are regulators, if you just put them into low value, so they will give you low light. If you put them into high value, they will give you more light. And there is a transistor circuit. Why do you require a transistor which gives you an electronic control to instrument lights? Okay, low base currents in transistor control variety of lighting circuits. So transistors are used to control which circuit to be operated at what particular time. Otherwise what will happen, it will mismatch. Let's say during emergency all the lights will glow up, whereas only emergency light should glow up. In the same way, during a normal condition emergency light may glow up. Okay, so in order to avoid that, in order to distinguish, to give a distinguished operation or distinguished lit up of all the lights at different times whenever it is required, transistor circuits are used. Okay, particular transistors and resistor circuits are used particularly to lit up one light only at a particular time when it is required, not all together. Okay, and you have got other things like radio navigation system, fuel panels, compass, engine indicators. Over here also low base currents in transistor control can actually control all these lights that are used in radio navigation system, panels, fuel panels, compass, and your engine indicators. Fine. Then instrument panel. It is constructed of per, perspex material. Remember that. This is not yet a DGCA question, but it can actually come. Sorry, this is already a DGCA question. It can actually come, and it has come also many times. With what material is it made? It is made with perspex material. Electroluminescent panels means LED panels, which I have already said. Electroluminescent LED. LED panels are used aircraft power and energy efficient, because we know that LED is consuming very less current nowadays, right? And it is used with AC power. Remember that. Phosphorus material glows when AC power is applied. Phosphorus material will glow when AC power will be applied. Next we have got master warning lights. Master warning lights will come whenever there is a warning situation. Located within the pilot's immediate view. It will be just in front of the pilot deck. When he is looking in front through the cockpit window, so that he can locate those warning lights. So it will be exactly in the level of his eyes. Okay. In the event of failure or malfunction, closure of either switch causes its corresponding light to illuminate together with master warning. In case of any big malfunction or problem that occurs, it will be with a master warning thing, it will actually illuminate together. Okay, all those things will be lit up together whenever there will be a particular problem when observed in the system. So master warning or caution light cancelled by pressing the light option. There is a light option. The particular light where it is glowing, if you press that light, there is a button basically. If you press that button, the master warning light will go off. But that does not mean that if the warning goes off, that does not mean that the problem has gone off. You have just kept quiet. You have told the warning system to keep quiet, that you shut up. I understood there is a warning. So you have just made the system shut up, but that does not mean that the actual problem has gone off from the system. The actual problem is still there, it still persists. Okay, so do remember that just by pressing the or just by shutting off your warning system does not mean that your problem is gone. The problem is there in the aircraft. Okay, and the panel may have up to 50 individual warning lights. That's not that important. Anyway, we go to the next point where it is said that individual light located on overhead or side panel. Individual systems are identified by a system name. The system light will be different and it could be tested. Whenever there is a test switch for every light, like for emergency system and such systems, when it is not always required, those systems would be tested. Okay. Night and day switch is used to either decrease or increase the intensity of the warning lights. Right? In the night time, the intensity will be less because less light is required for warning systems. In the daytime, the warning system light will be increased, intensity will be increased, because otherwise in the daytime we may miss out the warning lights due to too much of sun rays coming inside the cockpit or anything. Okay, so at that time intensity will be increased. Warning could be of red if it is unsafe condition. If it's caution, then it will be amber in color, which is almost yellowish and orange color. Okay, abnormal condition and is not unsafe. Okay, if it is advisory, means there is some advisory or some status it is showing, it could be in green or blue. Okay, means it's a safe condition or for just for information purpose. Okay, these are the three levels of warning and these are the four different colors. Passenger cabin lights. Now when you go to the cabin section, where the passengers are sitting, okay, so it will be exactly according to the interior condition of the aircraft, where you are keeping the things and all. Okay, normally there are roof mounted lights also, and there are cabin mounted lights as well. So the passenger cabin light control from flight attendant station, means from the flight attendants, the cabin crew, from their station where they are standing or sitting, from there you can control all the lights if you want. Plus the passenger reading lights of a particular passenger seat can be controlled from each seat only. From each seat a passenger can control his own passenger seating light. Okay, that much of freedom has been given to a passenger. Entry floodlights are provided in door areas. Entry floodlight means when the passenger is getting inside the aircraft, so near the door there is a good lighting provision given. Now exit light is what? Exit light means these are the lights which are basically mounted on the emergency windows, emergency doors and all those areas. Okay. Wherever there is an emergency exit, there will be exit light which will be on. Which will be on whenever there is an emergency situation. Okay. So that you can easily go and open the door and you come to know that where is the particular door. So that particular light will be glowing during emergency. The exit light. Okay. Floor path lights are there which are mainly used for emergency situation. As I already told you, it will give you a you will see from the cockpit till through the cabin till the last of the aircraft. Okay, till the end of the rear section of the aircraft, there will be series of light in the floor. Okay, just beside your seat. If you get up in the aircraft, you'll understand why that is given. That is given so that during any smoking condition or any night condition when there is no light inside the aircraft, those lights will glow. There is emergency power supply, emergency battery, which will glow those particular light during the case of emergency situation, so that you can understand like where is the floor and from which side I have to go. Okay, so that's the reason these floor lights are given. So it guides the passenger during emergency. Remember that. Then we have got exterior lights. In exterior lights, there are many lights. In exterior, we can see there are many lights. First light is a logo light. That is basically there in the tail section. In the radar area, wherever the aircraft is having its logo, okay, company logo. So it is basically just to aware people in a busy airspace or busy airport that a particular aircraft is waiting. So how do you come to know in the night time which aircraft is waiting in the bay, which aircraft is there? So that when that logo light will be flashing, no, when the logo light will be put on the logo, so by looking at the logo, we will come to know whether it's Indigo, whether it's Vistara, whether it's Air India, whether it's something else, right? So that's the reason it is given. So it is basically there in the tail fin where there is a logo. Okay, and that's the reason only all the logos are kept in the tail fin only, because aircrafts are made with such a type of a configuration that all the logo lights are given at the tail portion. That's the reason the logo is also printed or the logo is also painted at the tail portion only. Fine. Now taxi lights, this is very important, or runway turn off lights. It is also called as runway turn off light. Now understand the meaning of runway turn off light. Means after landing, okay, or after takeoff, taxi light means runway turn off light. Runway turn off light means in runway you turn it off. When you do that, when let's say you are landing or you are taking off, during that landing or taking off condition in the runway strip, you do not require that light. You only require it till you are taxiing it to the runway, or after you have landed and then you are going through the taxi, then you switch it on. So before taxiing you switch it on from the runway, or just after completing the taxiing, when you have reached the runway, now you will be going for the takeoff roll or takeoff run. Before that you switch it off. That's the reason it is called runway turn off light. Means in runway it will not work, it will not be operated in runway. Runway only the landing light will be on. Fine, before landing or before takeoff. Now 250 watt filament lamps are used. This is one most important thing. Then we have got it improves the visibility during ground operations. Taxi lights. During ground maneuvering, taxi lights are basically used when the aircraft will be taxiing with its own power, with own engine power, when it is moving in the ground. At that time it will increase a lot of visibility. Runway turn off lights on wing routes, it is there. In some aircraft it is there in the wing, some aircraft it may be there in the landing gear also. Okay, and it is automatically switched off with gear retraction. The moment you retract the gears, okay, that the landing gears are retracted into the wheel well area, the lights will glow off. So aircraft is in motion, taxi lights are on aircraft is motion as warning to other aircraft and vehicles, which means that when aircraft taxi lights will be on, so it will basically give a warning to the other aircrafts that there is a aircraft which is moving, just like the headlight of your vehicle, right? What is the headlight of your vehicle doing? It is giving some information. Sorry, it is giving some information to the aircraft that is coming from front. It is giving some information to the vehicle which is coming from front that you are coming, right? So in the same way, aircraft which is having its taxi light on, that also gives some information to the forward aircraft or the aircraft which is parked at some other position in the airspace or airport, to make it understand that you are or your aircraft is coming. Okay, by the help of the taxi light you can make that understand. Now landing lights, these are very important. These are mainly you will find at the wing tips or sometimes in the front of the fuselage, or usually fixed at some angle, with the wing also it may be there, wing mounted. Generally it is wing mounted nowadays, or it is at the bottom of the fuselage also. It is sealed beam. It is having 600 to 1000 watt filament. The taxi light was 250 only because you do not require very high power. But landing lights you require very high power, because aircraft with that high speed, when it lands, it requires a very powerful light to see what is there in front at night, what is there in front, or what is there in the runway. So it requires a very high power light. Okay, and usually the degree of this particular light is around 11 degree. Remember that 11 degree of radiance means at 11 degree it radiates. Okay, the degree of radiation, if it arcs, it is 11 degree only, means it is very focusing light. Okay, there is a parabolic reflector, okay, which concentrates the light into 11 degree. Okay. Alternative locations for the landing light could be the wing leading edge, I already told you, and inward and outboard landing light provide extended illumination of landing areas. Now, wing illumination, fine. So, in wing illumination, what is there? Ice inspection lights will be there. If there is ice formation, then those ice formation could be checked from the aircraft, inside of the aircraft only, whether it is whether some ice has formed on the wing leading edge or engine intake or not. So, there are ice inspection lights. Okay, generally it is 50 to 250 watts, and it is recessed into fuselage, means it is like flushed with the fuselage, it is put inside the fuselage. Okay, service lights are there. Service lights will be in many places: hydraulic bay, in the landing wear areas, in some complicated areas, pneumatic charging areas, hydraulic lifting areas. In some cases it may be near the AP, it may be near the engine oil refilling area, wherever in the fueling area, wherever you have to service the aircraft, wherever some servicing is required, over there will be a service light separately kept. Okay, that navigation light, this is very very important. At night we can see all the navigation lights. Okay, one light we can see at the left is always red color. Remember, red means left party in India, all the left political parties are red. So that's how you have to remember that left is red. Okay, and right parties are all green. Okay, I'm not mentioning any party name. Right parties are all green, right political parties. So right is always green. In that way you have to remember. So left side is having red color, right side wingtip is having green color. Fine. And also there is two white color strobe lights which also will flash along with the red and the green light, it will be there. Okay, also one white light will be there, or white or yellow light, generally it is white light at the tail portion. Fine. And along with that you have got beacons. Beacons are anti-collision or emergency lights. Whenever the aircraft is turned on, the beacons are on. Whenever the engine is on, the beacons are on, and only after the beacon is off, after that only you should go to the aircraft. When the beacon is on, you should not be stay close to the aircraft. Okay, so night flying, beacons are a legal requirement. You have to keep the lights on at night, otherwise no aircraft can find out where you are. Okay, generally filament based lamps are used for and provides a steady illumination. And okay, regulations are there which define the color, the location, the beam divergence. Beam divergence means what angle should be there. So green color, the starboard wing or the right side wing will have a divergence angle of 110 degree of light. These I have already discussed previously also. Red color will have also 110 degree. The clear white tail light will have 70 on both sides, which means 140 degree. So together if you sum up all these values, 110 on left, 110 on right, and at the back 140, means 360 degree of light. Means a aircraft can be located from all 360 degree angle. That's how the lights are designed. That's how the lights are radiated from an aircraft. From the left 140, from the right from the left 110, right 110, and from back 140. So 110 110 is 220 plus 140 means 360 degree. So all 360 degree of coverage will be given by these three lights. Okay. White light is usually at the tail cone or fin tip. Trailing edge of the wing tip also you can keep it. Usually the wing lamps are 20 watt only, and tail lamp is 10 watt. So it is a bit more powerful. The wing tips lamps are a bit more powerful. Okay. And fine. controlled with a single switch, which means if you put on the navigation light, all three lights will glow together. Then there is an anti-collision light, which is also could be called as a strobe light. Okay, like there could be a rotating beacon, there could be a combination of a strobe light and rotating beacon both. Rotating beacon means the light will rotate in all directions. You must have seen in the at the top of the ambulance also there is this type of lights, or police vehicles or minister vehicles. The light is rotating. Okay, so just like that over here also there can be rotating lights. And okay. Strobe lights are located on the vertical stabilizer, wing tips, tail, lower wing surface, and fuselage. All these areas wherever it should be visible, wherever there may be a chances of the aircraft getting collided, over there this particular light will be kept. Okay, as an anti-collision light. It is also controlled by a single switch with single protection device. Single protection device means fuse, basically fuse. Fuse is basically used to protect the light. Okay, it should be used in conjunction with the navigation light always, so that will be a better thing. So navigation light will be on, the left, the right and the back. Along with that the strobe lights will also be on. Then there is rotating beacon that we have already read. It is having a driving mechanism in which the filament bulb will be reflected through a reflector and the motor will rotate that bulb in all directions. Okay, so generally the question is how many flashes takes place in a rotating beacon. It is 40 to 50 times per second. Remember that, not per minute, per second. Per second there will be 40 to 50 times flash. And it located on the tail fin or upper or lower fuselage. Usually we find in the upper fuselage one beacon, red color beacon is there, and in the lower fuselage also one red color beacon is there, and it will flash almost together at the same time. Strobe lights are usually there at the wing tips and tail fin areas. Okay, white flash of 1 microsecond duration at approx 70 flashes per minute. So anti-collision or beacon is 40 to 50 times per second, and this is 70 flashes per minute. This is also a DGCA question. Remember, it could be white or could be red also. Generally it is white, strobe lights, because beacon is red. Okay, and sealed beams are there. So many external lights are based on sealed beams, and the beams are all sealed. Okay, so that you cannot touch it with your bare hand. So sealed beam combines incandescent filament lamps and reflectors into a single assembly. Reflector concentrates the lights beam, okay, and it will make it focusing. Just like we have a reflector behind every torch that we have in our house, there is a reflecting material you must have seen behind the bulb or behind that LED, which will reflect all the lights and point in one direction. Okay, it will converge all the lights and make a focusing light. That's the reason reflector is used. And lastly, there is a filament lamp is inserted through a hole in the near of a reflector and retained by the locking mechanism. Also with this I am mentioning one more thing, that is you should not touch a strobe light with bare hand, because in your hand there may be moisture or oil, which if accumulates on the surface of the strobe light, it will crack that surface, because it is very high temperature surface and heat will be accumulated with that oil and water from your hand. Those areas, if heat is accumulated, it will break that glass. Okay, the glass will be broken, so that will damage the light. So never touch a strobe light with your bare hand. That's it. And that's all about it. That's the simple revision. So in this way you have to quickly go through again and again all these things. So from my part, I'll try my best to complete all the majority of the questions if possible. From your part, you have to keep revising the PDFs that are there. Okay, thank you so much.